Lesson 3 of chapter 4. We're solving inequalities now, but we're using multiplication or division. So before we were using addition or subtraction, now we're going to do it. What happens if we have to use multiplication or division? So the same properties of inequalities, the same kind of rules apply as when we would add or subtract. So remember, whatever you do to one side, you have to do to the other. I will say multiplying and dividing, there is kind of a twist here. And this is really, really important to understand. So the multiplication and division property of inequality. When you multiply or divide each side of an inequality by the same positive number, the inequality will remain true. So when it's a positive number, as long as you're doing it to both sides, it remains true. However, this is where it gets tricky. When you multiply or divide each side of an inequality by the same negative number, the direction of the inequality symbol must be reversed or flipped for the inequality to remain true. So you might want to put like a big star here. This is very important. If you multiply or divide an inequality by a negative number, you have to flip the inequality sign. And I'll show you what I mean by that. So let's take a look. Our first set of examples, you can notice I wrote the words positive. We're just dealing with what happens if we multiply or divide by a positive on both sides. So let's work with that. First one, solving an inequality using multiplication. So x right now is being divided by 5, and it's saying it's less than or equal to negative 3. So to get rid of dividing by 5, I'm going to multiply by 5 on each side. Notice we're multiplying by a positive. I'm just left with x. We're going to bring down our same inequality sign because we multiplied by a positive. And now let's evaluate that. Negative 3 times a positive 5 gives us a negative 15. That's our solution. Go ahead and graph that to the right. Hopefully you're putting negative 15 towards the middle. You could be labeling every one. I'm just going to make sure I have at least one number to the left, one number to the right. You should have a closed circle at negative 15. And your arrow, since this reads x is less than or equal to, our arrow should be going to the left. Now let's solve an inequality using division. So right now we have 6x is greater than negative 18. X right now is being multiplied by 6, so I'm going to divide each side by 6. So I'm left with x. Now take a look. I divided by a positive, so that means my inequality remains true. I just bring it down. Negative 18 divided by a positive 6 gives us a negative 3. That's our solution. So now go ahead and graph it. Negative 3 should be in the middle. You could be labeling every single one after that. You could just do a few. I really don't have such a specific preference as long as you are labeling correctly, knowing where your numbers go. So now you should have an open circle at negative 3 with your arrow to the right because its x is greater than negative 3. So that was if we multiply or divide by a positive number. That's essentially what this first property was telling us to do. Okay, let's take a look at what happens if you multiply or divide by a negative number. This is where, like I said, it gets a little tricky. So if you notice, right now n is being multiplied by negative 3 over 2. To get rid of that, we're going to divide by negative 3 over 2. Or if you remember our trick, dividing by a fraction is the same as multiplying by its reciprocal. So let's multiply by its reciprocal. Its reciprocal is just when you flip that fraction. Right now it's 3 over 2, so I'm going to make it 2 over 3. That'll cancel all this out, and I'll just be left with n. Whatever I do to the left, I have to do to the right. Notice, I am multiplying each side by a negative number. So when you multiply by a negative, in order for your inequality to remain true, you have to flip your sign or your symbol. So right now your symbol says less than or equal to. I have to flip it so that it's greater than or equal to. And now let's actually evaluate this. So I might cross simplify. 2 times 2 is 4. Positive times a negative gives me a negative 4. Now this is my solution. N is greater than or equal to negative 4. Now let's label our graph. Might jump over and just say 4, so this would be 5, 6, 7, I don't know, negative 7, negative 4, 3, 2, 1. This should be an open circle. Just kidding. Closed. To see if I would trick you. So closed circle because it can equal it. And now read that aloud in your head if you need to, or out loud. N is greater than or equal to negative 4. Greater than or equal to. So greater. Where a number is greater than negative 4, to the right. That should be your graph. Let's do another one. Solving an inequality using division. Look at your variable z. Right now it's being multiplied by negative 3. In order to get rid of that, I'm going to divide by negative 3. I'm dividing by a negative. So maybe before you even do that math and get caught up in it, set up your solution. I'm left with z. I have to flip it because I'm dividing by a negative. And now let's do that division. 4.5 divided by a 3. 3 can go into 4 once. Three can go into 15. Make sure you brought up your decimal 5 times. And that finishes that off. A negative divided by a negative gives us a positive 1.5. That's our solution. Now let's graph it. You can put decimals. I can say, oh, 1 would be here now, 2 would be here. This should be an open circle with my arrow to the left because z should be less than 1.5. So the biggest takeaway from solving with multiplication and division is if you multiply or divide by a negative, you must flip your inequality symbol. And we'll discuss that more as to why does that happen? Why do we have to remember to do that? And things like that. We'll also practice a ton more. Hopefully graphing your solution is becoming easier because we're doing it so much. The newest thing you need to remember is when you multiply or divide by a negative, your symbol flips. If you multiply and divide by a positive, everything just carries down the same as when we add and subtract, so on. It's when you have